Okay, for part 1 of Math 272 Test 1 review, we have in the first problem, you're looking at determining the area as well as the volumes generated about the x-axis and the y-axis, and we have given the functions y is equal to 2x plus 2, y is equal to 0, and we have the activity going on between x equals 0 and x is equal to 2. Correction, between x equals 0 and x is equal to 3. So we have in the layout Okay, so in the two-dimensional modeling, okay, so we have, now the figure is not drawn according to scale, okay, but what we have here, okay, so you have y is equal to 2x plus 2, y is equal to 0, and again we have with the boundaries, okay, so you have going on between x is equal to 0 and x is equal to 3. For what we have in the corner points, so we have 3, 8, 3, 0, the origin, and 0, 2. Okay. Now, we have in the determination of the area, okay, so if you notice between x equals 0 and x is equal to 3, okay, so y equals 2x plus 2 is going to be above y is equal to 0. So we have just for the area, and we have with limits of integration, so we're going from x is equal to 0 to x is equal to 3. Then we have the upper function minus the lower function. So that's just going to be at 2x plus 2. And we have integrating with respect to x. So in the case of the two-dimensional area, we have with the antiderivatives. So for 2x, we have x squared. And for 2, antiderivative is going to be at 2x. And we have at 0. Okay, so the function is going to be negligible. So everything in the area is going to be riding upon the upper limit. So we have 3 squared is 9, 2 times 3 is 6, 9 plus 6 is going to end up at 15. So for the area of this particular quadrilateral, okay, this will be 15 square units. Now, in what we have with regard to the determination of volume, and we have, in the case of determination of volume, whenever the solid is generated about the x-axis. So in terms of how the solid is going to appear, and I'll be able to utilize, okay, the method of disks. Now in the two-dimensional drawing, okay, now the height, okay, we're going to have at 2x plus 2, and that's going to be the radius. So again, we have the radius at 2x plus 2. And now, in the case of utilizing the method of disks, so we're going to have for the volume generated about the x-axis. Again, so we're looking at going from x is equal to 0 to x is equal to 3. And we have pi times the square of the radius. And for what we have in the case of following through. And I can just go ahead and square the binomial expression. So if I just take what I have here. So I have for 2x plus 2 quantity squared. Okay, so we have 4x squared. We got 4x plus 4x, which will be 8x. And in the case of 2 squared, okay, that is going to be a 4. And taking what we have in the antiderivative. Okay, so we have pi times quantity, so I have 4/3 x cubed. Antiderivative of 8x will be 4x squared. And then we have plus 4x. As x goes from 0 to 3. And so for what we will have in terms of the volume generated about the x-axis. Okay, so everything is going to be riding upon the upper limit. And so just looking at plugging in, okay, the value of 3 in this particular case. And okay, so for leaving what we have as a multiple of pi, so we have for the volume generated about the x-axis, okay, this will end up at 84 pi cubic units. Now, and what we have regarding the volume of the solid generated about the y-axis. And again, we have, okay, for the setup, okay, we had this particular quadrilateral. And if we were to maintain, let's say, integration with respect to the variable x, okay, so in this case, now we can rely upon the method of shells. Okay, and so just for taking what we have here, okay, so we have revolution about the y-axis. Again, for the projected radius, okay, you have p of x is equal to x. And once again, we have in terms of the height, h of x. Again, so we have the upper function minus the lower function. Okay, like what we had in the case of determining the area. So h of x we're going to have at 2x plus 2. And again, we'll be looking at the method of shells. And for what we have for v of y. Okay, so we have with the limits of integration. So again, I'm going from x equals 0 to x is equal to 3. And I have 2 pi times p of x. Okay, so that's going to be at x. Times h of x. So that's going to be at 2x plus 2. And we have dx. And so for what we have in the case of following through, so in taking the product, okay, so I have 4 pi x squared plus 4 pi x dx. And just working with what we have for the antiderivatives. So I have 4/3 pi x cubed plus 2 pi x squared. Again, as x goes from 0 to 3. And we have for this particular outcome, okay, the volume generated about the y-axis is going to be at 54 pi cubic units.